All right, everybody. So what we are going to be covering today is something called coterminal angles. This is a brand new concept. But before we get into coterminal angles, I want to go over the technically labeled theta and how that works. So normally you start off right here on the x-axis. Now, what this is called the initial side. Now, however much you move this up, that center angle is called theta. So let's go move it up to, let's say we move it up to 120 degrees. So we take this initial side right here and we slide it up to 120 degrees. Boom. This new side is called your terminal side. And theta would be 120 degrees. All right, initial side and terminal side. Now, what coterminal is let's say this. Let's say, what is sine of 120 degrees? Let's figure out sine of 120 degrees. Well, sine of 120 degrees, you would just draw the angle right here, and your reference angle would be 60 degrees, right? To give you back to the x-axis, this would be your triangle. And the side, so I'm going to redraw this triangle right here. This is 60 degrees, 90 degrees. Here is your xy coordinate plane. So the side across from the 60 is root 3 over 2. The side across from the 30 is 1/2. But remember, this is a negative 1/2 and this is 1. Therefore, sine of 120 degrees would be a reference angle right here. And sine is opposite over hypotenuse. So if you were to go opposite, which is root 3 over 2, over 1, sine of 120 degrees is equal to root 3 over 2. All right, well, that's all nice and dandy, but now let's say this. Let's take this and let's add 360 more degrees to this. Notice if we add 360 more degrees, I'm back where I started. So if I were to do, let's say if I were to ask you, what is sine of 480 degrees? Technically, here it would be 360 plus another 120 would give me 480 degrees. Now look, notice how this is the exact same thing. You're in the exact same location. What if I were to add another 360 degrees to this? Rotate this again, another 360 degrees. And what if I were to ask you, what is sine of 840 degrees? It would be the exact location. Your reference angle would still be 60 degrees. Each one of these is called a coterminal angle. Now, what a coterminal angle is, it's any angle that has the same initial side, which is right here, and terminal side, which is right here. So no matter how many times you rotate this 360 degrees, you're back at this exact angle. Or the exact opposite. Let's take 120 degrees, but now what I'm going to do is I'm going to subtract 360. So now I'm going to go this way. So if I were to say sine of 120 degrees is right here, but if I were to subtract 120 from 360, I would get sine of negative 240, which would give me, boom, right here. What if I were to subtract 360 again? I would end up at the same exact spot. So let's say I ask, what is sine of negative 600 degrees? it's coterminal to negative 240, which is coterminal to 120. The reason why it is coterminal, is because you have exactly the same location every single time. That's why in the notes I say, you can think about it like this. Whatever theta is, if you add or subtract 360, not both of them, but if you add 360 or you subtract 360, you're going to be in the exact location as you already are. This is the technical definition of coterminals, when you have theta and you add or subtract 360 to it. So, with that said, let's take, let's do radians now. Let's say pi over 2, which is, boom, right here. Give one positive coterminal angle. Well, how do we find a coterminal angle? We're going to take, look, theta, which is pi over 2, and we are going to do one, because we're located right here. We just raised this, boop, right here. We're 90 degrees, which is pi over 2. Now I'm going to add 360 degrees to it. But if it's in radians, we have to keep it in radians. So I'm going to add 2 pi over 1 to pi over 2. Well, this is simple adding fractions. Pi over 2, this has to be a common denominator of 2, and this has to be multiply this by 2, so I multiply this by 2 to get 4 pi. Notice 4 pi over 2 is the same as 2 pi over 1. So pi over 2 plus 4 pi over 2 is going to give me 5 pi over 2. 5 pi over 2 brings us the exact same location. What if I were to do a negative? What would be a negative coterminal angle to pi over 2? Well, you got it. You would just do pi over 2 minus 360, which is 2 pi over 1. Another way to write 2 pi is pi over 2 minus 4 pi over 2, because 4 pi over 2 is the same as 2 pi. 4 pi over 2 means you've rotated twice. You've gone one full rotation, I mean. Anyways, pi minus 4 pi is equal to negative 3 pi over 2. So if I'm here and I go back this way, I've gone almost, look, I've almost gone a full rotation. Negative 3 pi over 2. Okay. Every one of these are coterminal angles. Now, what we are going to do is, let's look at, it's asking you to find some positive and negative coterminal angles or radians. Let's start off with number 1, 75 degrees. What I'm going to do first is this. I'm going to figure out where I am. 75 degrees, let's say, is about right here. All right. Now, what is one positive coterminal angle? Well, if I were to do another full rotation, which would mean I would take theta plus a full rotation. So my calculator, 360 plus 75 is going to give me 435 degrees. And then I can just add 360 infinitely. If I add another 360, I'm at 795 degrees. So 795 degrees is coterminal to 435 degrees, which is coterminal to 75 degrees, because look at your original angle where theta is. This is your initial side, and this is your terminal side. You always end up at the exact same spot. So if you were to do 795 degrees, you would go 1, 2, and you'd end up at that location. Okay, let's try and find a negative coterminal angle. Here's 75 degrees. Negative coterminal angle would be theta minus 360. So minus 360, I'm going to go backwards a full rotation. So 75 minus 360 degrees is going to give me negative 285. So if I were to ask you what is sine, cosine, and tangent of 75 degrees, it would be the exact same answer as saying, let's get rid of the 75 and say, what is sine of negative 285 degrees? Which is going to be the exact same answer as what was my positive coterminal angle. My positive coterminal angle was 435 degrees. Sine of 75 degrees is the same as negative 285 degrees, which is the same as positive 435 degrees. So sine, cosine, and tangent would be the exact same for all of these. And then what happened when I add another 360? It's the same as 795 degrees. Hopefully you guys are understanding this concept because you end up in the exact same spot. Okay, now with that said, let's do a positive and a negative coterminal angle of the second one. 2/3 pi. Now, I'm not going to convert this into degrees and reconvert it into radians. You could do that if you want, but look, what if this was 3/3 pi? This would equal pi. This would convert to pi, which is right here. But this is the thing. We are pi/3 less. We are, so if I were to do this, we are pi/3. My reference radian would be pi/3. How many degrees is pi/3? 60 degrees. So 2 pi/3 has to be 120 degrees, which it is. So if I were to figure out where 2/3 pi is, it would, if I had another pi/3, I would be at 3 pi/3, which would be pi right here. I'm just kind of mentally walking you through. You don't need to do it like this. You can just convert it to degrees and figure it out. Or, anyways, this is where I would be. My reference radian would be pi/3. This is 2 pi/3 right here. Anyways, you don't really need to draw this, but I'm just drawing this to kind of show you where you are at. So I would have, if I were to find one positive and one negative coterminal angle, I don't really need to see it, but I'm just explaining it to you to make it make sense to you.